My dear students, Vanakkam. We are in progress of discussing solid state in chemistry. In the previous session, we discussed about the characteristics of solids and the types of solids. So yesterday I told you that there are two types of solids, namely crystalline solids and amorphous solids, and I explained, also illustrated the differences between these two types of solids. So as I told you yesterday, our main focus is on the crystalline solids only in this unit. So next we move on to the next topic, that is classification of such crystalline solids. The crystalline solids are classified into four different types based on two aspects. One aspect is the nature of the particles present in the crystals. And the second is the nature of the force holding these particles in the crystal. So I told you yesterday, the particles present in the crystalline solids are either atoms or molecules or ions. So based on the nature of the particles, we can classify the crystals. And I told you yesterday that the constituent particles in crystalline solid are held together by attractive forces. So they are the nature of the force. They can be weak van der Waals force, ionic bonding, covalent bonding, metallic bonding, etc. So based on the force and based on the nature of the particle, we can classify the solids, crystalline solids, into four different types. So one is ionic solid, another is covalent solid, the third is molecular solids, the fourth is metallic solids. So let us discuss one by one. So the name itself, ionic solid, implies that the constituent particles are ions. We know ions are charged particles. In the ionic crystal, the constituent particles are cations and anions, positively charged cation and anion. You can consider sodium chloride crystal as an example for the ionic crystal. In sodium chloride, we do not have NaCl molecules. It may be surprising. See, in the ionic crystal, molecules are not present, only ions are present. In sodium chloride crystal, sodium cation and the chloride anions are present in large number. These ions are held together by strong electrostatic force of attraction. So this is the nature of the force that exists between the constituent particles. We know the force between the charged particles are quite strong. So these are stronger, harder crystalline solids. The attractive force is maximum in this ionic crystal. To maximize the attractive force, each positive ion is surrounded by many number of negative ions. Similarly, each negative ion is surrounded by many number of positive ions. So this will maximize the attractive force. So for example, in sodium chloride, if you consider this as sodium ion, it is surrounded by 6 chloride ions. One in the front, another in the back, the third at the top, fourth at the bottom, fifth in the right side, sixth in the left side, in 3 dimensions. So each ion is surrounded by 6 oppositely charged ions. So the attractive force is very high. This leads to close packed structure for the ionic crystal. That means ions are very closely arranged. So So this is called a close packed structure. So they have a regular arrangement in the crystal. We are going to study the structure of the crystal later in the same unit. Because of the strong electrostatic force of attraction, the ionic crystals show very important four characteristics. Number one, they possess very high melting point. As the ions are held by strong attractive force, it is difficult to break the force. We have to give more heat energy to separate these ions. So they possess high melting point. About conduction of current, the ionic solids do not conduct electricity in the solid state. It may be surprising, sir. They have positive and negative ions which are responsible for conducting current. Then how come it is a non-conductor? See, remember, these ions are held by strong attractive force. So they cannot move, they are in a fixed position. Say they do not conduct electricity in the solid state. Then how they conduct electricity? They become good conductors either in the molten state or in the aqueous state. When dissolved in water or melted, the attractive forces are overcome, the ions are free to move, so they become very good conductor of electricity. So they are good conductors in the molten or aqueous state. They are naturally hard crystalline solid because of the close packed structure, because of the strong electrostatic force. We need greater energy to displace the ions. So they are very hard crystals. So this is about the ionic crystals. Next, we move on to covalent crystals.